Welcome to the deep dive. Today we're really getting into CHAR Technologies. They're a Canadian clean tech company doing some pretty interesting work with waste.
That's right. And this deep dive is aimed straight at you if you're curious about how innovation is, dealing with waste management and helping build a more sustainable future.
Yeah, because CHAR Technologies seems to be hitting a few key problems head on.
Exactly. It's not just about like the mountains of organic waste we generate. It's also this really tricky issue of forever chemicals, PFAS, getting into everything.
Right. And the constant need for cleaner energy, cleaner industrial materials, it's a lot.
It is. They're tackling sort of a complex bundle of challenges.
So our mission today is pretty clear. Break down what CHAR Technologies actually does. We want to understand their tech, their impact, and their future potential.
And we've got info from the company itself, some recent news articles. So we should have a good base.
Great. Let's jump in. Where do we start? What's the core technology here?
Okay, so the heart of it all is something called high-temperature pyrolysis.
Yeah.
HTP for short.
High-temperature pyrolysis.
Okay. In simple terms, you're heating organic stuff up really hot, over 800 Celsius. But crucially, with no oxygen around.
No oxygen, so it's not burning it in the usual sense.
Exactly. It's thermal decomposition, breaking it down with heat, not combustion.
Got it. And I saw the term autothermal mentioned. What does that mean in practice?
Yeah, that's important. Autothermal means basically once the process gets up to temperature, it generates enough energy to keep itself going.
Oh, so it fuels itself, more or less.
Pretty much. It makes the whole thing much more efficient, reduces the need for external energy to run it. Better for the environment, probably better for the bottom line too.
Makes sense. Less energy in, more efficient output. And what kind of organic stuff are we talking about? Can it handle anything?
It's pretty versatile, actually. Things like wood that can't be sold as lumber, leftovers from farming, agricultural residues.
What about things like biosolids? Sewage, sludge?
Yep. Even biosolids, which can be a real headache for cities because of potential contaminants, and other general organic wastes, too.
Yeah.
That flexibility is a definite plus.
Okay, so they cook this wide range of waste without oxygen. What comes out the other end? What are the valuable products?
Two main things come out. First, you get renewable syngas.
Syngas, synthesis gas, right?
Exactly. And it's rich in hydrogen, which is key. Now, this syngas isn't always the end product itself. It's more like a building block.
A building block for what? What can you make from it?
Well, you can upgrade it. One big pathway is producing green hydrogen. We hear a lot about that for, decarbonizing heavy transport industry, stuff that's hard to electrify.
Okay, green hydrogen, that's big. What else?
You can also upgrade it to renewable natural gas or RNG.
RNG, so that can go into the existing gas grid.
Precisely. It blends right in,
Right.
lowering the carbon intensity of the natural gas we use. Or the syngas can just be used directly on site to generate heat and electricity.
Wow, okay. So waste go in, and you can potentially get hydrogen fuel, cleaner natural gas, or just power. That's quite a conversion. What was the second main output?
The second one is biocarbon. You might also hear it called biochar. It's basically a solid, very stable material that's packed with carbon.
Biocarbon or biochar. Okay. Is it just one thing, or are there different types?
It's not just one thing. They can actually tailor its properties for different uses. It's quite versatile.
Like what? Give me some examples.
Well, one really exciting one is Biocoal. This stuff can actually be used as a direct replacement for metallurgical coal.
Metallurgical coal, the kind used in making steel and cement. That's notoriously dirty.
Exactly. And CHR's Biocoal could potentially cut the greenhouse gas emissions from that process by up to 91%. That's huge.
91%. Hold on. That's almost eliminating the emissions from a core industrial process.
It's a massive potential reduction. If that scales up, it can make a real dent in emissions from heavy industry, which is a really tough nut to crack.
Okay, that's definitely an aha moment right there. Biocoal. What else can this biocarbon do?
They also make a specialized version called SulfaCHAR. Think of it as activated carbon designed for a specific job.
Which is?
Cleaning up gases. Specifically, it's really good at pulling hydrogen sulfide out of biogas, the gas produced when organic matter breaks down anaerobically, like in digesters.
Ah, so improving the quality of biogas.
Yeah.
Makes sense. Any other uses?
Yep, the one people might be more familiar with, using biochar as a soil amendment.
Right, putting carbon back in the ground.
Exactly. It helps the soil hold onto water better, makes nutrients more available to plants, can boost crop yields, plus it locks away that carbon for a really long time, centuries even. Carbon sequestration.
So cleaner energy, greener industry, better soil, and carbon sequestration. That's Quite the package from one core technology.
It really covers a lot of bases.
Okay, let's shift gears a bit. How are they actually using this HTP tech in the real world? I saw something about a project in Baltimore.
Ah, yes, the Baltimore PFAS destruction pilot. That one's getting a lot of attention. CHR calls it a landmark project, and I think they're right.
They're working with Sinagro and the city, right?
Correct. Synagro, who are big in biosolids management, and Baltimore's Department of Public Works, it's tackling a really nasty problem.
PFAS, those forever chemicals. What's the specific issue they're addressing there?
Well, PFAS chemicals are incredibly persistent, they don't break down easily, and they pose health risks. They tend to concentrate in municipal biosolids, the sludge left after wastewater treatment.
So cities have this PFAS contaminated sludge and need a safe way to deal with it.
Exactly. It's a huge disposal headache. Landfilling can lead to leachate problems, incineration isn't always perfect, and can create other issues. This pilot aims to show that CHR's HTP system can actually destroy the PFAS in those biosolids.
Really destroy them.
That's the goal, to break them down at those high temperatures without oxygen.
Wow. If they can prove that consistently,
Yeah.
what are the implications?
Oh, it could be massive, a real game changer. It offers a potential solution for potentially hundreds of municipalities struggling with this exact problem. It could lead to regulatory buy-in and really position CHR as a leader in PFAS remediation.
And are they still getting the useful outputs, the Syngas and Biochar?
That's the plan. Recover the Syngas for energy and produce a biochar that's now PFAS-free, making it potentially safe for land application again.
Turning a liability into an asset.
That's incredibly promising.
Yeah.
So besides this critical PFAS pilot, what other major projects are moving forward?
They've got several key growth projects on the go. There's the Thorold facility in Ontario. That one's focused on converting wood waste and other organics into RNG and biocarbon.
Thorold, Ontario. Did that get funding?
It did. Pretty significant funding, too, back in 2022. Over 11 million Canadian dollars, which definitely shows confidence in the project.
Okay. And wasn't there something happening in Quebec as well?
Yep, the Saint Felicien project. That one's interesting because it's a collaboration with First Nations communities.
What's the focus there? Producing high-quality biocarbon and green hydrogen, specifically from forestry residues. They've got funding lined up for that too, and it's in the development stage now. Shows that hydrogen focus is real.
Forestry residues. Using waste wood for hydrogen? Makes sense. And one more, I think, near Lake Nipigon, also in Ontario.
Right. The Lake Nipigon Forest Renewable Energy Facility, again, using wood that isn't suitable for lumber, sourced sustainably. The goal there is also RNG and biocarbon.
Any recent news on that one?
Yeah, they just got over $5 million from Canada's Clean Fuels Fund earlier this year, in 2024. They're aiming to start construction in 2025. So good momentum there, and again, working with Indigenous partners.
It definitely seems like they're moving from concept to actual build-out across multiple sites. Are they partnering with other companies too, besides the project-specific ones?
They are. Building strategic alliances seems to be a key part of their strategy for scaling up.
Like who?
One important one is with the BMI Group, which operates across Canada. They're working together to co-develop and roll out these renewable energy facilities using CHR as tech.
So BMI helps them build more plants faster.
That seems to be the idea. And just recently, actually, May 2025, BMI invested $2 million through a private placement, providing more capital to fuel that growth.
Okay, that's a strong vote of confidence. Any international partnerships?
Yes, they're also teamed up with Hitachi Zosen Inova HZI. They're a big global name in waste to energy.
HCI. What's the focus of that collaboration?
They're looking at combining technologies, specifically integrating traditional anaerobic digestion, which HZI is known for, with HDR's HTP process.
How would that work?
You could potentially pre-treat waste with anaerobic digestion to get biogas, and then use HTP on the leftover solids, the digestate, to get more syngas and biochar. Kind of a best-of-both-worlds approach for maximizing value from waste. They're targeting North America and Europe with this joint approach.
Interesting. Combining established tech with their newer HTP process. But let's zoom out again. Thinking about the big picture, what's the overall contribution CHAR Technologies is making?
Well, fundamentally, they're contributing to the circular economy, right? Taking waste that might otherwise go to a landfill.
Where it produces methane, a potent greenhouse gas.
Exactly. And instead, turning it into valuable resources, energy, and materials. That's circularity in action.
And we keep coming back to the emissions reduction, especially that potential 91% cut with Biocoal replacing metallurgical coal. That seems like a really tangible climate benefit.
Absolutely. That's a huge lever. And it's not just theoretical. They got that U.S. $3.8 million grant from Natural Resources Canada in April 2024. Specifically, then there's the agricultural sector, dealing with crop residues, needing soil amendments, heavy industry, like steel and cement, looking at that biocoal,
Right, the big emitters.
energy utilities and gas companies interested in the RNG and maybe green hydrogen down the line,
Mm.
and even the forestry sector, looking for sustainable outlets for wood waste. It's a broad church.
A very broad potential market then.
Yeah.
And just for practical info, for anyone listening who wants to follow them more closely, they are publicly traded.
Yes, they are. CHAR Technologies Ltd. Trades on the TSX Venture Exchange. The ticker symbol is YES.
Yes. Got it. Okay, as we wrap up this deep dive, let's try to crystallize the main points. What are the absolute key takeaways about CHAR Technologies?
I think the core thing is their innovative HTP technology. It offers a really promising way to handle organic waste sustainably. It's not just disposal, it's transformation
Transformation
into valuable things, renewable energy like green hydrogen and RNG, and these useful biocarbon products, Biocoal for industry, Biochar for soil, and crucially, that added potential for destroying harmful PFAS chemicals, like in the Baltimore pilot. That's a major environmental service.
Right. So for you listening, if you wanted to quickly get up to speed on a significant player in the clean tech space, hopefully this gives you a solid grasp of Higher Technologies' work and its potential impact.
Definitely. And maybe a final thought to leave you with. We've talked about biocarbon for industry, for soil, for cleaning gas.
Yeah.
Given how versatile this material seems to be, what other maybe unexpected industries might find uses for it down the road? What other innovations could spring from just exploring this stable carbon material further? Something to ponder.